If Boeing is the name on a plane, many travelers hesitate before booking and for understandable reasons. The short-haul flight experience has long been marred by three main frustrations: unreliable schedules caused by maintenance delays, noisy turboprop engines that make takeoffs and landings disruptive, and constant vulnerability to late departures. But imagine an aircraft that wipes out all these issues in one bold leap forward. An aircraft that needs no runway, that lifts off vertically into the sky, and that delivers quiet, fast, and reliable travel. That's the vision Elon Musk is preparing to bring to life with the highly anticipated 2026 Tesla super electric plane, a groundbreaking innovation poised to revolutionize regional air travel forever. This upcoming Tesla aircraft represents a total rethink of short-haul aviation. It's designed not as a luxury experiment, but as a practical, efficient, community-focused solution for routes up to 500 miles. The focus is on simplicity, consistency, and environmental performance. Its cabin will accommodate between 4 and 12 passengers, making it perfect for regional routes and smaller airports, often overlooked by major airlines. Yet what makes this plane revolutionary isn't just its design, it's how it transforms every stage of flight. From boarding to battery swaps to scheduling, instead of waiting hours between flights, the Tesla super electric plane promises astonishingly fast 15-minute turnarounds. It achieves this by using modular battery packs that can be swapped instead of recharged on the spot. While traditional aircraft spend valuable time refueling or waiting for maintenance checks, this electric plane will simply exchange its depleted batteries for freshly charged ones, keeping downtime to an absolute minimum. These batteries recharge offline, ensuring continuous operation and maximizing flight time throughout the day. Noise pollution has been one of aviation's biggest local obstacles, especially at community airports surrounded by residential areas. Tesla tackles this problem head-on with whisper-quiet electric motors that make takeoff and landing almost silent. This means the plane can operate early in the morning and late at night, during hours that have always been restricted for conventional turboprops. By opening up these once closed time slots, local airports can now serve more passengers, and airlines can schedule more flights with minimal community disruption. From a reliability standpoint, the Tesla super electric plane is engineered to cut downtime dramatically. Electric propulsion removes many of the complex moving parts that traditional engines depend on: gearboxes, exhaust systems, and fuel pumps, to name a few. With fewer mechanical points of failure, the plane offers consistent assembly line precision and performance rather than the maintenance-heavy unpredictability that plagues current short-haul fleets. Inside, Tesla applies its well-known design philosophy of comfort through minimalism. The cabin may be compact, but every inch is efficiently used. Seating configurations of 1-to-1 or 2-to-1 create aisles that are up to 20 inches wide, enough room for passengers to pass comfortably without brushing shoulders. Boarding has been simplified too. A large low door and a single step allow quick, easy entry. That same wide doorway is designed to handle cargo containers and even medical stretchers without any special tools, allowing the aircraft to rapidly switch between passenger, freight, or emergency service roles. Quick-release seat rails make reconfiguration possible in just minutes. Every aspect of the structure emphasizes durability and ease of inspection, crucial qualities for a plane expected to complete multiple flights per day. Tesla combines corrosion-resistant aluminum with composite panels to achieve an optimal balance of strength, weight, and longevity. Panel seams are placed strategically so mechanics can inspect them easily without needing to disassemble interiors. Even the seats and restraint systems exceed crash safety standards, ensuring that passengers remain protected even in rough landings. Engineers have designed the aircraft to endure tens of thousands of flight hours before any major structural overhauls are needed. Noise reduction isn't treated as an afterthought. It begins with the aircraft's very shape. The super electric plane's aerodynamic design features smooth wing surfaces and refined wingtips that minimize drag, which extends its range while also reducing the loud pressure fluctuations passengers typically hear during descent. Enclosed landing gear eliminates the familiar whistle and rumble sounds of turboprops, Propellers are carefully sized to ensure their tips never cross the supersonic threshold, preventing high-frequency noise that carries into neighborhoods. The result is an aircraft so quiet that it redefines the limits of acceptable noise levels at community airports. This quiet operation, combined with electric propulsion, allows airports to expand their operating hours, increasing the number of available flights per day. The improvement in on-time reliability is substantial. By eliminating delays linked to noise restrictions and maintenance unpredictability, Tesla ensures passengers can count on punctual departures and arrivals. Underneath its sleek exterior, the Tesla super electric plane is built for serviceability and speed. Components like inverters, motor controllers, battery management systems, environmental controls, and avionics are housed behind easy-access panels instead of being buried beneath trim or cabin fixtures. Each system is built as a line-replaceable unit, which means any malfunctioning part can be swapped quickly using standard tools. Every connection is color-coded and keyed to prevent mistakes. Ground crews can replace modules in as little as 5 to 10 minutes without removing seats or panels. And Tesla standardizes fasteners across the airframe to simplify maintenance. Digital manuals linked via QR codes help track part history and repair logs, turning aircraft upkeep into an efficient, data-driven process. The battery modules themselves are held in place by guided latches and interlocks that make swapping foolproof. No need for specialized equipment or lengthy safety checks. This streamlined system allows the plane to complete its 15-minute turnaround window with precision every time. In practice, this consistency transforms how regional airlines operate. The plane's schedule revolves around two key numbers: a 500-mile range and a 15-minute ground turnaround. Each landing sets off a perfectly timed sequence. The plane parks, passengers deboard, and new passengers board, its process taking only 2 to 3 minutes. Baggage handling happens simultaneously. Battery swapping takes 6 to 8 minutes, while automated system checks complete the remaining tasks, compared to the typical 25 to 35-minute turnaround times of traditional regional aircraft. Tesla's system effectively doubles operational efficiency. This precision means more flights per day with far fewer delays. On routes under 250 miles, a full cycle of taxi flight and turnaround fits neatly within 60 to 90 minutes, allowing one aircraft to complete 10 to 16 legs per day. Even on longer routes of up to 500 miles, the aircraft can handle 6 to 10 daily flights numbers that conventional planes simply can't match without excessive wear and tear. This consistency has another major benefit: predictable schedules. With its fixed turnaround time, the Tesla plane ensures that short-haul travel becomes as dependable as train service. Passengers will experience genuine door-to-door time savings. What used to be a grueling 3 to 5-hour drive becomes a smooth 90-minute journey, including boarding and transfer times. The efficiency isn't only in the air, but also in the infrastructure the aircraft can use. Thousands of small, underutilized community airports across the world, especially in rural or suburban areas, can now serve as convenient hubs for Tesla's new plane. Instead of driving long distances to reach major airports, passengers could fly from facilities much closer to home. The quiet nature of the plane also means these local airports can extend their operational hours, offering early morning and late night flights without disturbing nearby communities. This flexibility creates more travel options for passengers and allows airlines to maintain better on-time records. From a cost perspective, the Tesla super electric plane stands to slash operating expenses dramatically. Electric propulsion doesn't just mean sustainability, it means simplicity. The direct-drive electric motors eliminate gearboxes entirely, reducing moving parts and streamlining inspections. These motors achieve astonishing efficiency levels between 90 and 95%, converting nearly all input energy into forward thrust rather than wasted heat. Each motor operates independently, adding redundancy. If one motor fails, others automatically compensate, allowing the aircraft to continue its flight safely and on schedule. This redundancy is critical for maintaining safety without the added complexity of Traditional engine systems. The modular battery packs are designed for rapid handling by ground crews. Each battery block is light enough to maneuver quickly and safely, making battery replacement as routine as refueling a conventional jet, only faster, cleaner, and cheaper. Because batteries can be charged separately and offline, aircraft aren't tied up on the tarmac waiting for power. This innovation drastically reduces ground congestion and keeps flight schedules tight and efficient. By combining vertical takeoff capability, modular battery design, low maintenance requirements, and ultra-quiet motors. Elon Musk's 2026 Tesla super-electric plane represents a bold step toward the future of aviation. It's a solution built around efficiency, reliability, and sustainability.